Hello, everyone. I hope you all are doing good. So, in the previous classes, we were studying about normal distribution and student T distribution. And normal distribution was considered as our reference distribution. Okay. So, continuous data can be represented in form of normal distribution. Okay, that is expected because normal distribution is a reference distribution. All right, it's a reference. It's not mandatory that you are having a continuous data and it will show behavior of normal, but it is like expected that it should have to be normally distributed because normal distribution is our reference distribution, and there are many reasons for it. And it's an important distribution because properties of normal distribution says that it is symmetrical, it is having bell shape, it is having mean median mode all equal. Okay, so we are having measures of central tendency, they all are equal. We are getting a symmetry also. So it is easier for us to analyze. Fine. Rather than, because continuous we have to represent data in intervals. Okay, so obviously here histogram distribution plot will be made. Fine. So if we get like a reference kind of a distribution whose formula is known to us, and I have written multiple times the formula of normal distribution, that is 1 upon square root of 2 pi sigma e की power minus x minus nu whole square divided by 2 sigma square. Okay, and your normal distribution look like this. Fine. Okay, and this is your line which represents the mean median mode all equal, and obviously there is a symmetry, left hand side and right hand side both are same. Okay, so such kind of distribution is expected when your data is continuous in nature. Okay, in most of the real world problems we do use normal distribution. Okay, and obviously while dealing with probability, okay, and random sampling, okay, fine, obviously such plot is very much important, it's contributing, it's highly contributing. In statistics and probability, normal distribution is highly contributing. Okay, here we are having nu and the sigma present in the formula, and these two are the parameters. These two are the parameters which help us in defining how data is distributed, mean and the standard deviation. Okay, nu is the mean, sigma is the standard deviation, and standard deviation means the variance. Okay, so everything which I require to acknowledge data, I am going to see here in the normal distribution. Okay, so randomness is also there, probability is there, statistic is there, everything is there in normal distribution. So it's very much important. Only the thing is, in order to represent data in normal distribution, we should have a huge amount of data. huge amount of data. Okay, not few data points will be likely to be normally distributed. No, that is not the case. We should have some good number of data. So, in case we don't have, for example, then student T came. That's the reason. Student T, because getting such type of shape, getting such a type of shape definitely require a data which is good in number. Then only we can achieve such kind of shape. Okay. If we are not having such amount of data, we are having sample, only sample of data, then instead of normal distribution we are having student T distribution. Student T, I also taught this thing. The only difference between student T and the normal is, see, student T is a bit heavy, and it looks like a normal only, but it is having heavier tails, and not as much as peak as the normal does. Okay, so it looks like, okay, this is student T. Okay, where we are having sample of data. Okay, fine, small data. Okay, and as I taught, if the number increases, okay, if the number increases, if the sample size increases, then the student T gets converted into normal only. Okay, according to the theorem, according to the property, that's what we call as an central limit theorem, CLT. I'm going to talk about CLT today, central limit theorem. So, what you are having in data science and machine learning, everything revolves around the data and its distribution. Okay, we are studying data and its distribution only, how points are present in a space. So to understand about the data, we should have some reference plots. Then only I can understand. If there is some irregularity, for example, like this, what you are going to talk about this data distribution? Nothing. Do you have any scope to talk about anything about this data distribution? No. But if you are having data in this particular format, you can speak something about it. You know what could be the mean. You know what could be the standard deviation. Okay, so such data distribution like normal student T, we learn and we expect, or if it doesn't have the data, we don't have the data in normal format, we try to convert it, we try to transform the data into normal distribution. Again, the same reason, I want to study the data. Unless and until I don't convert it into regular format, normal format, reference format, understandable format, how can I study the data distribution? Okay, either it can be like skewed. Okay, it can be skewed, left skewed, right skewed. I already explained each and everything. Peakness, tailedness, everything I told. Skewed data. The skewed data or peakness or the tailness in the data is showing deviation in the data. That means it is biased. We never expect biased data. That means it is being oriented to some specific data points. No, we want the distribution of the data to be uniform, like normal, as what I said. This should be the distribution of the data. It should not be like specific. Okay, then only I can analyze and then only I can give some predictive results over it. Else the entire calculation, the entire analysis will be like biased only. Okay, so we have to keep this thing in our mind. So student T distribution is a small level normal distribution. The bigger level is normal distribution. That means you are having a huge amount of data, you are having actually population. that is normal distribution, and student t is sample. Okay, and when this sample increases towards a population, student t will be going towards the normal distribution. And this is said according to the central limit theorem, CLT. Okay, so what is CLT? Let me share my entire screen and we'll discuss about the CLT now. Okay, so central limit theorem. Fine. Here it is, central limit theorem. So what is CLT? It states that the shape of the original population distribution, that is the distribution of the sample mean, approaches towards normal or bell shape as the sample size increase. So that's what I already told you. When the student t approaches to normal, that is central limit theorem. And this is because the sample size increases. Okay, so you are working. Okay, let us suppose this is your data. Okay, you are having the data points present in it. If you are taking a sample of the data, this is a sample, you can make student t distribution of it. But if you increase the sample, you can make normal distribution of it. That is central limit theorem. Okay, because with the sample you are having a mean x bar, with population you are having nu. Okay, and obviously if the data points increases, the distribution, and there are many changes occur. Okay, in terms of the property. All right, fine. Now, so that's what central limit theorem says, that it we were being take many random samples from the population and we calculate the mean of each sample. Then the distribution of those sample means will tend to approximate the normal distribution. Okay, take many samples. Take sample 1, take sample 2, take sample 3. Take as many as samples you want to take from the population. You are having, for sample 1 you are having x1 bar, sample 2 you are having x2 bar, sample 3 you are having x3 bar. These are the means of the sample. And it's saying that the distribution of the sample means, that means make the distribution of mean, make the distribution of mean, that will behave as a normal distribution regardless of the shape of the original data. कोई फर्क नहीं पड़ रहा original data what is the shape. You just take as many as sample possible. Okay, let me again make the diagram. This is your population. You took this sample S1, you took this sample S2, you took this sample S3, you took this sample S4. Mean of this sample x1 bar, x2 bar, x3 bar, x4 bar. So it is saying that, according to the central limit theorem, it is saying that x1 bar, x2 bar, x3 bar, x4 bar, these mean of the sample, if I make a plot for it, if I do plot it, it will look like normal distribution. That's what it is saying. Very important property, central limit theorem. Okay. For example, if we are at a carnival surrounded by many people of different height, like tall, small, and medium, so if you take the average height of the population, the people present in the carnival, if you take the average height of the people, okay, let us suppose we are having 50 people and the average height is x1, then we can take a random another 50 people, average height is x2, and so on. If you do that, and if you plot all these averages, what do you think? How they will look like? It will create a bell curve shape, and this distribution is normal in nature. That's what it is telling. This is central limit theorem. Okay, got it. एंड इट्स प्रूव्ड प्रॉपर्टी. ऐसा नहीं कि सर आप बोल रहे हो कि ऐसा हो जाएगा तो ऐसा हो ही जाएगा. नहीं, ये प्रूव्ड है. ओके, फाइन. It's already proved. So as the sample size increases, the distribution on the sample average tends to be a normally distributed. ये होता है. It's a property. All right. So the various steps which a central limit theorem do follow. Okay, that means we can define the population. We can define the parameter of interest. That means identify the population, and the parameters are our mean and the standard deviation. Okay, you can take the height. Okay, the kind of data on which you are working, take the height. If you are talking about the height of the individuals, okay, you can take the mean height from them. Okay, fine. And then you can choose the sampling method. Okay, you can perform the random sampling of the data. Fine, you can draw a random sample. You can calculate the mean of the samples. Okay, determine the size of the sample. Each random sample should be of the same size. For example, if you are drawing 50, okay, you are having 2000 people present in the carnival, and if you are drawing 50 data points, so whatever be the sampling you are doing, as many as samples you are collecting, that should be all of 50-50. So sample 1 is also 50, sample 2 is also 50, sample. Don't change the sample size, then again it will be an issue. Okay, we never change the sample size. Okay, it will be in a same number. Fine. All right, so don't change it. Okay, keep it fixed. So as many as samples you are drawing, okay, keep the same number of samples. Okay, the data points in the sample. So for example, 50. So every sample is having 50 points, but they are randomly selected. Okay, so we are collecting the data. We are doing the random sampling from the population according to the chosen sampling method. There could be any sampling method we can use. Okay, we are applying here random sampling, randomly picking up the data. We can calculate the mean of them. Okay, just calculate the mean, and then this process is repeated. Collect as many as samples, calculate the mean of them, and then we can analyze the sample distribution. That means we can make histogram, we can make dist plot, we can make any kind of plot. Okay, and it should look like normal. Okay, it should look like normal. That means we have to check check that CLT is met or not. CLT is met or not. So we did perform random sampling. We are having independent observations. Okay, and if the sample size increases related to the population, does if the any of the assumption is violated, adjust according to what is necessary. Okay, right now it told that the CLT theorem says that if you are going to draw the plot for the sample means, it should look like normal. If it is not behaving like a normal, do the adjustment. Again, perform the random sampling. Okay, so check the assumptions, and if it is not following, then reperform your task. That's what you have to do. Okay, fine. So here, conduct test. Once you have obtained the sampling distribution, sample mean, you can do the test. Confidence interval, hypothesis testing. This is what I'm going to teach ahead. There are many kind of tests we can do. Okay, fine. So that is what central limit theorem is. Okay, the sample size increases, it's likely to be a normal distribution. That's what the CLT says. Okay, so CLT is robust. It can apply to wide range of population distribution. Whether the data follows a normal distribution, skewness, whatever, as long as the sample size is sufficiently large, the distribution of a sample mean tends towards normal. So if you are having the large data, if you are having many samples, you calculate the mean of the samples, You draw the plot the sample means, it will be tend towards the normal. वो अपना बिहेवियर यही बताने की कोशिश करेगा कि मैं नॉर्मल हूं. Okay, fine. As the sample size increases, the distribution of sample means becomes increasingly closer to the normal. See, it is repeating the points ना again and again same. कि सैंपल इंक्रीज होगा तो नॉर्मल, इंक्रीज होगा तो नॉर्मल, दैट्स इट. बार बार वो यही बोल रहा है और यूनिवर्सली एप्लीकेबल है. Okay, it applies not only to continuous data but also to discrete data, even if multivariate data also. This makes CLT a versatile, widely applicable tool in the field of study of science, engineering, economics, and so. That's what I told. The kind of plot, the kind of data distribution which we are learning are applicable to various fields. Okay, and everything it tends towards the normal. ये हमारा तो यूनिवर्सल रूल है ना, यूनिवर्सल रूल है. Who don't want to be like a normal? I also want to be like a normal. Okay, if I am having some issues, some health concern, okay, I want to be as a normal. Everyone wants to be as a normal. Let the things get solved. Normal. Nobody wants to be like as a skewed. Normal. So that's what it is saying. Data point increasing. Doesn't matter you are continuous. Doesn't matter you are discrete. See, discrete we are not taking into the consideration right now. It told that okay, it is applicable, but continuous, especially continuous. Okay, fine. So when to deal with the CLT theorem? Okay, whenever you are having large sample of data, that's it. And with the population that are not normally distributed, we do perform statistical inferencing, hypothesis testing. That's what we do, and we look out for whether we can have this data to be in normal distribution or not. Okay, what are the applications of CLT? Hypothesis testing. Okay, we'll learn hypothesis testing. Okay, financial analysis, survey, educational assessment, biostatistics, CLT. Okay, what are the limitations? Okay, dependent upon the sample size. See, everything depends upon the sample size only. CLT is meant for sample size only. Sample size should have to be large. Small sample size, no CLT is applicable. The small sample size means student T, and we don't have to work on the student T. We have to work upon normal distribution. Sample size should have to be more. Dependence on independent, that means assumes that individual observation within each sample are independent of each other. Okay, so samples are independent of each other. That's what it assumes. However, there could be a correlation. It's not mandatory that every sample is independent. There could be a correlation in the features, there could be correlation in the data point. For example, time series data, clustered observations. There could be an dependency. Okay, sensitive to outlier. If we are having the data points, extreme values, extreme points, outliers, so they will influence the calculation of mean. Then you will not tend to normal. Then you will be every time you will see the okay deviation, skewness in the data. So it is sensitive to the outlier. Okay, CLT is robust to wide range of population distribution. It may not hold for distribution with heavy tails, extreme skewness. That's what I'm saying. Skewness, heavy tail, then it will be an issue. Okay, in such cases, alternative methods are used. Okay, anyways, this is central limit theorem. Okay, sample size more towards the normal distribution. That's what CLT says. A normal distribution, normal is what we want. Okay, what we want, normal. Okay, fine. So in my main notes also, same thing is present related to central limit theorem. Okay, fine. In central limit theorem, we are having estimator and the estimate. Estimators like mean, standard deviation, and the variance. These are estimators. Okay, these are the facts, these are the terms about the population. भाई मुझे कुछ कहना है ना डेटा पॉइंट के ऊपर, तो क्या कहूं, किस क्या लेकर कहूं? If I need to talk something about the data points, if I need to talk something about the distribution of the data, what I can say over the data? हाँ बहुत अच्छा है, अच्छे दिख रहे हो, ये थोड़ी ना होता, मैथ्स में मैथ की टर्म होती है. So if you want to say something about the data, there are estimators. I can calculate mean, I can calculate median, I can calculate mode, I can calculate variance, I can calculate standard deviation. So these are the estimators. Some statistical concepts. ओके, सो डेटा के बारे में बोलना है तो डेटा की शब्दों का इस्तेमाल करो. दीज आर एस्टिमेटर्स, एंड वॉट एवर बी द वैल्यू ऑफ एस्टिमेटर इज, इट्स कॉल्ड एज एस्टिमेट. फॉर एग्जाम्पल मीन इज 10, so estimate is 10. Mean is estimator and 10 is estimate. Variance is 5, so variance is estimator and 5 is estimate. Okay. Standard error. See, standard deviation indicates how far a value is from its mean, and standard error shows how far a sample mean is from population mean. Remember, IMP. Population mean and the sample mean, how far they are from each other. This is called a standard error. मतलब हम चाहते हैं पॉपुलेशन का मीन और सैंपल का मीन कोइंसाइड करे. कोइंसाइड लेकिन होगा कैसे? क्योंकि सैंपल तो छोटा है बेचारा, सैंपल इज स्मॉल, तो उसका मीन पॉपुलेशन के मीन के बराबर कैसे आ सकता है? हाउ? बिकॉज सैंपल इज स्मॉल, its mean will be small. Population is huge. Okay. So the difference between the population mean and the sample mean is called a standard error. And it is calculated by this thing, sigma upon under root of n, where n is the sample size. And sigma, obviously, standard deviation. Okay, fine. So this is your standard error. So estimator estimate standard error. Confidence level. अब भाई, अब यहां से थोड़ा सा हाइपोथेसिस टेस्टिंग और बातें शुरू हुई. देखो समझना पड़ेगा, आप ये खेल क्यों खेल रहे हो, ये वाई यू आर प्लेइंग, वाई वाई यू आर प्लेइंग with population and sample. Why? See, you are having a problem statement. Okay, that can be a financial problem, that can be a survey problem. Let us now pick up a survey problem. Easy उठा लो. सर्वे है, सर्वे कर रहे हो, सर्वे पॉपुलेशन, सर्वे प्रॉब्लम है तो उसमें पॉपुलेशन आएगी. सो यू आर डूइंग अ सर्वे. सो सर्वे में यू कांट कंसिडर एंटायर पॉपुलेशन, नहीं कर सकते. यू कांट कंसिडर एंटायर पॉपुलेशन. You have to consider only a sample of data in a survey, and we work on sample only. We do work upon sample and we give the results on sample only. Population पे नहीं देते भाई लोग, सैंपल पे देते हैं. ठीक है, तो क्योंकि पॉपुलेशन बड़ी चीज है, पॉपुलेशन इज अ बिग डील, सैंपल इज अ स्मॉल. नाउ, why you studied all this normal, student t, population, sample, mean, and why you are doing all this thing? See, you are having a problem, you are having a survey, you want to do that. You randomly selected data, you collected a random sample, and with this sample, You have to test or prove something. That's what you have to do. So there will be a statement. There will be a statement given over a sample of data. Okay. And this statement will tell you that, specific to the survey, for example, it will be saying, in your city, condition of woman is not good. In your city, condition of woman is not good. This is the statement. Okay. So sample, we are doing a survey. We went in the city, we talked to the different women and asked how you are feeling. If most of the women said not good, the statement is, in your city, condition of women is not good. Okay. With this particular sample, with this particular sample, we'll test the statement. And this is what is called as hypothesis testing. Hypothesis is a statement. तो भाई किसी भी स्टेटमेंट को प्रूव करना है, हवा में थोड़ी ना कर लोगे यार। जानकारी इकट्ठी करो, डेटा निकालो, अप्लाई करो, प्रूव करो। आप, यू गाइस आर डूइंग रिसर्च, यू गाइस आर डूइंग प्रोजेक्ट, तो क्या किसी चीज को बिना डेटा के प्रूव कर लोगे क्या? बिना अल्गोरिदम लगाए प्रूव कर लोगे क्या? भाई मेहनत करना पड़ेगी ना। स्टेटमेंट तो कोई भी दे सकता है। सो दिस इज द स्टेटमेंट, ये हाइपोथेसिस है। हाइपोथेसिस इज अ स्टेटमेंट। प्रूव करो इसे। प्रूव के लिए सर्वे करना पड़ेगा। सर्वे आप पूरे पे तो करोगे नहीं कि इन अ सिटी देयर आर मेनी वुमेन, so you're not going to talk to each and every woman, how are you? Okay, just randomly you have to pick up, and on that random sample, you have to test this statement कि भाई ये जो लिखा है ना कि तुम्हारी सिटी में महिलाओं की जो स्थिति है वो अच्छी नहीं है, प्रूव करके बताओ। अच्छा, जरूरी नहीं कि प्रूव करने में तो सही करोगे प्रूव, नहीं, ऐसा नहीं, गलत भी हो सकती, फेल भी हो सकती। ठीक है, आपको तो सैंपल कलेक्ट करना था। ओके, यू हैव टू डू दैट, यू हैव टू कलेक्ट द सैंपल, you have to apply over this hypothesis, this statement. Obviously there are some terms that will follow up because there is a proper approach, but right now I'm just telling you that in hypothesis testing, that's what you have to prove. Test karo. Okay. And here, okay, sir, you said you do not follow, sir. In what context, sir? Hypothesis testing. Okay, let me tell more about it. So, okay, just a second. I told that hypothesis is a statement. You have to collect a sample of data to test hypothesis, to test the statement. I require something to test. Okay, so you have to collect a sample of data to test this hypothesis, to test this statement, whether it is correct or not. I need to collect the evidence. I need to visit to some of the ladies and talk them. How are you feeling in your city? Is there any safety security or not? Is that proper or not? She will reply. Some may, some may not. Some may give positive, some may give negative feedback. I mean, there could be a different prospect. Okay, so we are studying population sample because of this only, hypothesis testing, very important application. And in this we are having confidence interval, confidence level. And now how this confidence came? See, the confidence level is the percentage value within which the parameter truth value will remain or fall. That means, suppose we have solved a problem with 95% confident, 95% means we'll get accurate result. Okay, now let me again give you an example. You are doing survey, okay, and according to survey, you found that there is a strong justification. There is a strong justification in terms of security of women. Okay, you got a strong justification in terms of security of women. Then they are safe. They feel safe in the city. You have to decide confidence that okay, I'm 95% confidence. According to the survey, what I did, I found that I'm 95% confident that women are safe in the city. So whatever be the survey I did over a sample, this will be this will be also applicable to population. If I do the same survey over the entire population, still the things will be same. I'm 95% confident. That is what called as a confidence level. So I did survey on small sample of the data. I worked on small sample, but I am 95% confident that if I do the same survey through the entire population, the result will be same. The answer will be same. That is confidence. 5% there is a chance that you may fail. That is called a significance level. Okay, you guys also throw a bet na, among your friends. I'm 100% confident that this will happen. You try. I'm 100% confident. You try. This will happen. My experience says that. You try. So, what is this 100% confidence level? Same thing here also. You are doing a survey on a sample of data. And on your survey, you are confident. I'm 95% confident. I'm 90% confident that the survey I am doing correct. The result which I got from the survey is correct. The hypothesis I will prove. And this hypothesis will be applicable for population also. Doesn't matter. That means if it's not failed on the survey sample, it will not fail on the population also. Population will also follow the same trend. अब की बार 400 पार, और तुम जानते हो कि हुई कि नहीं हुई. ठीक है, वो सब टीवी न्यूज चैनल वाले 400 पार, चार पता नहीं कहाँ का सर्वे कर लिया था उन्होंने. तो वो कॉन्फिडेंस पे चल रहे थे, दे वर इन कॉन्फिडेंस. हालांकि वो सिग्निफिकेंस लेवल ट्रू हो गया. ओके, फाइन. सो confidence level, This is confidence interval. The interval, the range in which we will get the truth value of confidence. That means the range within which you are going to get the value of the data points, that is confidence interval. Okay, so this is your confidence level, and this is your significance level. Okay, normal distribution, if I do make a plot, so if the range of values comes under here till here, so this is confidence, and 5%, that means this is a rejection. There's a 5% chance that your theory is rejected. This is significance level, it is denoted by alpha. So 95% confidence, that means here. Okay, 5% outside. You may have 10% significance also. It's not mandatory. It's a 95 is a final value. No, these are the reference values. You may have like this also. Okay, like this. This is 5% and this is 5%. 5, 5, 10%. So anything which comes under here is accepted. Anything which comes outside, that means either here or either here, rejected. So we are having a significance level of 10%. Okay, so anything which falls here in the confidence, this is the interval actually. This is the interval. That's what it said, interval. And this is confidence. This is the region where I'm saying I'm confident. Okay, and here there is a chance that I may fail. That's called as a significance level, 5% chance that I may fail. Okay, so the significance level of an event is the probability that the event could have occurred by chance. If the level is quite low, then the probability of occurring chance is quite small. We can say that event is significant. I'll give you more examples based upon it. Okay, but you have to remember this plot: confidence level, significance level. Okay, by chance it may happen that, okay, what you are expecting doesn't goes correct. Okay, fine. All right. So, hypothesis testing. It is a statistical technique, statistical analysis by which we can test, validate an assumption. तो भाई जब से ये तो बोल रहा हूँ, you are having a hypothesis, you are having a statement, and you are and this statement you are collecting a sample of data to see whether this statement can be proved or not, whether this statement is correct or not. Okay, so you want to test, you want to validate this assumption. This statement is assumed statement. The condition of women is not good in your city. प्रूव करो जरा इसे. तो प्रूव करने के लिए भैया सर्वे अर्वे करो. If you want to prove a statement, you have to do a survey. You have to collect the data points. जब तक बात नहीं करोगे तब तक कैसे पता चलेगा? सर्वे करो, पता करो, सैंपल इकट्ठे करो, फिर टेस्ट करो. Okay, so in hypothesis testing, we'll consider null hypothesis which is assumed to be true, and an alternate hypothesis which means false. So true and false. Obviously, na, either the statement will be true, either the statement will be false. There is nothing like no true and no false. Na. Either the statement will be true, that is null hypothesis. Either the statement will be false, that is alternate hypothesis. So you are having a hypothesis, you are having a statement. It can be null, it can be alternate. Okay. Null hypothesis is denoted by H0. Alternate is represented by HA or H1. So null hypothesis is default assumption or claim about the population. That's what I'm saying now. I am having sample, but I'm claiming for entire population. I am only available with the sample, but on the basis of that sample only I am claiming for the entire population that how is the status of women in the city. Okay, that is null hypothesis. An alternate hypothesis means if the null hypothesis fail, then obviously alternate hypothesis. That means whatever you have assumed, the result are contradictory. Okay, the result are contradictory. Whatever you have assumed. Fine. So we are having confidence level and the significance level. I did explain to you about that thing. Okay. So significance level, that means denoted by alpha. That means where you are going to reject the null hypothesis. That means 5% or 10%, whatever. This is that region where whatever you have assumed, you fail. Okay, you fail. It represents the maximum tolerance probability of making a type 1 error, which is incorrect rejection of null hypothesis when it is true. Commonly significance level 5%, 1%, even like that only. So you may have a 99% confidence, you may have 95% confidence, you may have 90% confidence. 90 wala bhi less hai. 95 and 99% confidence. So in 95% confidence, 5% is significance. 99% confidence, 1% is significance. Okay. And how you go through this task? You have to collect and analyze the data, perform descriptive statistics, inferential statistics. See, hypothesis comes under inferential. Okay, apply test. There are many tests. T test, chi square test, ANOVA, correlation, regression. There are many tests. Then you have to calculate a p value. P value is a probability value. Okay, you have to calculate a probability. Okay, assuming that the null hypothesis is true. That's what you have to assume. And then you have to collect the evidence. You have to collect the evidence against the null hypothesis. Collect evidence against the null hypothesis. If the value of p is small, that means you are having strong evidence against null hypothesis. That means your hypothesis is rejected if the value of p is small. If the value of p is more, if the value of p is more, then accept. So, with whom I am going to compare the p value? Alpha. So, in general, p value is compared with alpha. So, alpha, if you take 5%, its value will be 0.05. So, if the value of p is greater than equal to 0.05, then null hypothesis accepted. It is less than this rejected because it's already told. If p is less, the significance level, the evidence is considered significantly strong against the null hypothesis. Okay, and we are going to reject the null hypothesis because we are having alternate hypothesis. Okay, so everything is maths. If you are saying something, maths, prove it, apply some formula. You should have some threshold value, probability. Okay, so we can draw the conclusions. If the null hypothesis is rejected, it suggests that there is sufficient evidence against null hypothesis. There is sufficient evidence against the statement. There is sufficient evidence against the problem statement which is given to you. So alternate is true. And if the null hypothesis is not rejected, that means it is accepted. That means we don't have enough evidence against the null hypothesis. So alternate is rejected, null is accepted. This is hypothesis testing, a short introduction. So whatever you are going to do, you are going to apply over the sample. You have to find the p value, probability value, and you have to compare it with the significance. Significance is 1% or 5% or 10%. In general, 5%. So if the p is greater than 0.05, then okay, good value of p, accept null hypothesis. If it is less than 0.05, reject the null hypothesis, accept alternate hypothesis. Okay, fine. All right भाई, इतना ही potential है आज. Okay, let me stop presenting, let me stop